at simultaneous equations, but in this case we have three variables. So generally the previous videos, they all had two variables, x and y. The variables also had some powers, so therefore the simultaneous equation became non-linear. But in this case we have three variables. We have x, y and z. So we need to find the values of all three of these equations. So the way how we'll do this is that we'll find x and then substitute to find y and do the same to find z. So we have three equations, equation 1, equation 2 and equation 3. So the first way on how we can do this is by removing one variable. We need to remove one variable of this equation so that we can get two equations with two variables and then solve it like a normal simultaneous equation. So we have x plus y plus z is equal to 7, y minus z is equal to 3 and x plus z is equal to 3. I've written it in this form just so that it's easy for you to see that one variable represents one column. So we have x, we have y, we have z. So now we need to combine these three equations. We need to make these three equations into two equations with two variables so that we'll be able to solve it easily. So we combine equation 1 and 2 and we'll combine equation 2 and 3. And after we combine them, we will notice that one variable is actually eliminated from the equation, and that variable is z. So if we notice that in equation 1 and 2 we have plus z and minus z, so they'll cancel out, and equation 2 and 3 we have minus z and plus z. So this is x plus z, so that works. So the z goes away. So let's combine equation 1 and 2. X plus y plus z is equal to 7 and y minus z is equal to 3. Let's combine them. So we'll be adding them up because we have plus z and minus z, and we'll be getting rid of the z. So we have, this is the same as 0x because there's nothing here, and this is the same as 1x. So 1 plus 0 is the same as 1. So this just carries forward, and this is the same as x. So x plus 0x is the same as x. Now we have y and y, so we have 2y, so thus becomes plus 2y, and z and minus z, they go away because we have plus z and minus z, so they cancel out, and then we add 7 and 3, so that is equal to 10. So essentially what I've done is that I've just carried forward each and every term in a vertical manner so that I'm able to form this second equation. So I have this other equation. This is my second equation. So I've combined equation 1 and equation 2. I've added them up so I can eliminate one variable, which is z, and then I'm able to get a second equation. Note that when I'm combining the second pair of equations, equations 2 and 3, I need to eliminate the same variable. Always keep that in mind, because if I were to eliminate x in the first two equations, I can't in this case, but suppose if I were to eliminate x in these two equations and then I eliminate z in the next two equations, that won't make sense because I'll still have three equations. So always keep into account that if you're eliminating one variable, which in this case is z, in equation 1 and 2, you need to eliminate the same variable, which is z, in the next two equations, equations 2 and equations 3. So let's combine equations 2 and 3. Equation 2 is y minus z is equal to 3 and x plus z is equal to 3. Again, this becomes very easy because I'm just able to combine terms in a vertical manner. So this is 0x and this is 1x, so that's the same as x. I'm just adding them up. I'm adding these two equations. Then y again carries down, so plus y minus z and plus z, they go away, and 3 and 3 add up to form 6. So again, I've just added these equations down in a vertical manner. So I have 0x plus x is x, y plus 0y is the same as y, and minus z plus z, they go away, so that gives me x plus y, and then I have 3 plus 3, 6. So this becomes my second equation. So it's very important that you always look at all three equations and you figure out one variable to eliminate. I've figured out that z is common between all three equations, and therefore I'll be eliminating z. Suppose if you had another variable, say if if y was common between all the equations. Suppose if this was x plus y plus z is equal to say 5. So you have two variables that are common in all three equations, so choose which one is the easiest to work with. So here z was easiest to work with, plus it was common in all three equations, so I eliminated z, so I can get two separate equations with two variables x and y. So my two resultant equations are x plus y is equal to 6 and x plus 2y is equal to 10. Then it becomes very easy for me to solve these with the normal simultaneous equations method which we had been explaining in the previous videos. So let's solve this. I'll be eliminating, because elimination is much easier in these types of cases. Suppose if it was a power, then substitution. So elimination gives me x minus x. I'm subtracting equation 1 and equation 2. So x minus x is 0, 2y minus y is y, and 10 minus 6 is 4. So therefore y is equal to 4. I've just subtracted this equation and this equation to get y as 4. Now I will be able to find the value of x easily, because y is 4 and I have x plus y is 6. So x plus 4 is equal to 6, and therefore x is equal to 2. So I've got my values, y is 4, x is 2. So because I have got my values of x and y as y is 4 and x is 2, I'll be easily able to solve for z. So we can substitute the values into any of these three equations and we'll get our answer. So the easiest one seems to be the third one, x plus z is equal to 3. There's no y, so just forget about y in this case. So we have x plus z is equal to 3, and we know the value of x is 2. So we'll just substitute 2 plus z is equal to 3. Therefore z is equal to 1. So we've already got our answers. X is 2, y is 4 and z is 1. Because there's no y in this equation, I just left y out. I just used my x and I was able to solve for z. Therefore, for this equation, the solutions are x is equal to 2, y is equal to 4 and z is equal to 1. It's a very easy type of equation. It's just that you need to do some more work. Suppose if you had x squared plus say y plus z power 4 is equal to 7. So here we notice that this becomes a non-linear equation because there's no power 1. All of these terms, well, the highest power is power 4, which is not 1. So therefore this becomes a non-linear equation. These two will still remain the way how they are, linear equations. So if you have something like this, x squared plus y plus z power 4 is equal to 7, then the way how we would solve this is again the same way. Combine equation 1 and 2 and then combine equation 2 and 3 and select a common variable which you need to eliminate, but in this case do substitution method. So y is equal to z plus 3, and then from there on we can just substitute and get our answers.